Okay, hello guys, welcome back to algebra class. So this time we are going to learn about the rational function. So rational function, this one is the last part of the algebra lesson that we are going to do together. And it's pretty simple. So parent function, we have to think about parent function. So parent function looks like f of x equals 1 over x. Just like a reciprocal function. That's the parent function. So as you can see, x is in the denominator. And because x is in the denominator, as you know, you cannot have 0 as a denominator because it does not make sense if you divide by 0. Like that simply does not make sense. Some of you may think, isn't it 0? No. 0 over something, like 0 over like anything, like a, stuff like that can give you 0, but any number to the 0 does not exist. It does not make sense. You can even ask it to Siri, and Siri will say something dumb to you. Like, so, how then? What should we do? So, here we go. Let's graph it. Go to decimals, and you're gonna put y equals 1 over x. And as you can see, you're gonna see this two graph like that. So pretty simple. So you have a graph like this here. You have a graph like this here. That's how graph looks like. So we have an asymptote, two asymptotes. Do you see this graph is getting closer to the here and this graph is getting closer to here, like this line? That's horizontal asymptote, okay? Horizontal asymptote in this case is y equals 0. This is another asymptote that we have because simply x cannot be equal to 0, so it goes to here like that and it goes to here like that. So that's gonna be what? X equals 0. So it's a vertical. Usually it's easy to think that vertical line is y, horizontal line is x, but always remember when it comes to a line, it's kind of opposite. All right. All right. Let's talk about the end behavior. End behavior is pretty simple here. So we are talking about end behavior. Okay. So it does not matter which one you start first, but here let's start from the x. As x goes to positive infinity. Let me write it a little bit differently. Something that you're going to see in pre-cal. Limit x goes to infinity. That means, look at the, as x goes to positive infinity side. Do you see this x is going to the right side here? Where is it approaching to? It's going down, but it's not keep going down like that. It's getting closer to 0 here, isn't it? To this line. That's the end behavior. As x goes to negative infinity, y goes to 0. That's the end behavior for the positive. Also, as x goes to negative infinity, as you can see, if x goes to negative infinity, like left side, y is also what happens? As you go toward the like negative infinity, it goes to what? 0 again. Y goes to 0. So that's the end behavior. End behavior it's pretty easy concept. Is if you spend about 5 or 10 minutes thinking about that. So yeah, that's it. But there's another way of writing this one. If you think this one's too confusing, I can also write as x goes to infinity, y goes to 0. As x goes to negative infinity, y also goes to 0. Like you can write it like this. Either way, it's same thing. I prefer this one. But the reason that I wrote like this is because I saw in pre-cal, they usually write it like that, okay? But it does not matter which one you choose, okay? So here, let's talk about the negative paragraph function. So negative parent function is y equals negative 1 over x. So what happens if you put negative here? What happened to this graph? Simple, it's gonna flip. Okay, so this will look like this. Do you see this side switched? Like, so it's not switching like that. It's not this. This one is switched like this, reflected across x-axis. So reflected. Okay, that's what happened. But everything is same. This one, horizontal asymptote, is still y equals 0, and vertical asymptote, which is this, is still x equals 0. Let's see if end behavior has changed. As x goes to positive infinity, if you look at the right side, if this graph goes to the positive infinity, keep going to the right, y is getting closer to 0, right? And same thing for the negative infinity. As x goes to negative infinity, it's keep going down, but keep getting closer to 0, right? Because it will never go below 0, because they are asymptote. As limit x goes to negative infinity, y goes to negative infinity. So that's how it works. Good, so we're done with this. So that's a basic concept. We will come back to this one in 2 weeks about this part, okay? Because that's the main part. All right, let's talk about the what's that called? Property of the rational function here. Vertical asymptote and horizontal asymptote. So let's say you graph this one. So we start from the 1 over x like that. But now let's do this one. 1 over, let's put x minus 2 plus 1. You see graph moved a little bit to the right and a little bit up, like this graph. So what's gonna be happening is this one. So do you see this minus 2? That's gonna shift left and right. Remember x value, it moves a little bit opposite. So instead of minus 2, it's gonna move plus 2, like that. And then plus 1. So as you can see here, oh, wait a second. Yeah, just like that. You see? These are the asymptote, so as you can, and graph will move like that. These are the positive graph, okay? So what's the vertical asymptote gonna be? This is the vertical asymptote, which is x equals positive 2. Opposite of this one is gonna vertical asymptote, and horizontal asymptote, this one is gonna be plus 1. Y equals 1. That's how you do. What about this one? How is it gonna work? Plus 1. So it's gonna be like that here. Minus 2. It's gonna be like that. And then simple, you graph it like this. You're gonna graph it. So x equals negative 1, where y equals negative 2. Yes, by just looking at this, you can find this one without graphing it. But if you just do it like that, then you're gonna forget what it is. So that's why I'm strongly encouraging you to graph it as well. So those of you who did not print out the note, make sure to graph it and then write it, okay? So that it can be fair. So x minus 3, so it's gonna be what? Plus 3 here, because it's gonna be opposite, and plus 2, like that. So you're gonna graph it like that, here and here. So vertical asymptote is gonna be what? X equals 3. For horizontal asymptote is y equals positive 2. It does not matter whether you have a negative here or not. only thing that is gonna be different is this, like switching this side like that, okay? Other than that, it's same. Here, let's do this. X plus 2 minus 1, and then graph it. Like this. So it's gonna be what? Vertical eccentricity is x equals -2. Horizontal eccentricity is y equals -1. It's easy. So I believe other than this end behavior, this part is pretty easy to understand. Okay. And remember, this part is also a fact for graph transformation, something that we did last time. So here we go. Remember this? It says we start from f of x equal to 1 over x, and if function moved 2 units to the left, 3 units down. So here, let's write this one down. It says 2 units to the left. So remember, it's x value, right? Oh, why did I put 3? So what I'm gonna do is this one will change to 2 units to the left. So I'm gonna put x plus 2 because it's gonna move opposite. 3 units down, minus 3, and what? Stretched by factor of 3. So I'm gonna put 3 here, or instead of here, I'm gonna put 3 here. Yep, that's it. That's the graph transformation. So let's do this one. Same thing here. 1 over x is just what? 3 units to the left. So I'm gonna change this one to what? Left, so it's plus 5 here. And then 5 units down, minus. Oh, why did I put post here? I'm sorry. And what? Stretched by factor of 3. So I'm gonna put here multiply by 3. So it's gonna be what? Y equals 3 over x plus 3 minus 5. All right. Now it's gonna be getting interesting. Now we have this one. So it will act same for other thing as well. So I have 1 over x minus 1 plus 3. We start from here. It says what? 1 unit to the right, which means what? Minus 1, right? So we're gonna do minus 1 here. 4 units down. So from plus 3, we're gonna do minus 4. Reflect across the x-axis. So we're gonna put negative. What is that gonna be? -1 over, what's a -1 minus 1? Like this. 3 minus 4, minus 1. That's a graph transformation that you're gonna see on the test. Not only this one, but you're gonna see like this for exponential and logarithmic as well. So keep that in mind. Let's do this one. So try this one by yourself, and then pause the video and check your answer, okay? 3 units to the left, so it's plus 3, so it's gonna be x minus 2. And 2 units down, minus 2, so it's gonna be minus 9, and reflect, so I'm gonna put negative here. Yep, that's it. What about this one? So this one is another type. We start from here, 1 over x minus 3, and that's gonna happen. Multiply by 2, and then what? Plus 1 inside for this one. So it's gonna be what? Y equals 2 over x, -3 plus 1 is minus 2. You might wonder, like, how come I don't change sign here? Because it was already inside the parentheses, so I don't have to change here, okay? So try this one by yourself. Pause the video and try it by yourself. That's what you're supposed to get, all right? All right, so it's gonna be same thing for you. Try it by yourself. Let me just go over this one. So here, 1 over x. It says 7 units to the left, so it's gonna plus 7 here because it's the opposite. 5 units up, so plus 5, and then compressed by factor of 1/5, which means you have to multiply with 1/5 here, right? So this one will look like this. 5 is in the bottom, so you can either write it like this or plus 5. That's how it works, okay? Because it's compressed. If it's stretched, you gotta move it up here because it's gonna be 5 over 1, like 5. but it's not gonna be a problem here. These two, it's literally same as this. This two is literally same as this, so it's not gonna be a problem. So if you have any questions, just let me know. In that case, I'll help you. All right, that's it, guys. See you. Love you.